this video we're going to learn how to calculate determinants of 3 by 3 matrices. In matrix C, right here we have 3 rows and 3 columns. And we're going to find the determinant, which, as you'll remember from class, is given by this notation right here. It's basically these bars that surround the letter of the matrix, the name of the matrix. And what that basically was for a 2 by 2 was, you'll remember, just kind of like multiplying diagonals and then subtracting the products. For 3 by 3s, it's much more complicated, and there are basically 3 methods. So I'll go through all 3 methods here, and you can basically choose your favorite one. So let's start with the one that is named after French mathematician named Pierre Laplace. So he basically said that we're going to use a form of expansion, right? It's also called cofactor expansion. Alright, so this first method right here we're going to call Laplace expansion, or cofactor expansion. And what it basically says is we're going to take a look at the first entry in first row, first column. We're going to write that down. Now we're going to multiply that by the determinant of a minor matrix. Now what that means is, it's kind of strange, but a minor matrix is basically everything except the row and the column that the entry is in. So for example, we're looking at the number 3 right here. We chose that one. That one's in row 1 and column 1. So we're going to kind of black those out for a second, and we're going to take a look at the determinant of the remaining matrix, the minor matrix. So that'll go right in here. 0, 3, 3, and -2. Okay? So then we're going to move on to the middle term, first row, second column, right here. And it's kind of an interesting little rule here. We're going to want to take the opposite of that. So it's sitting there as a -2. We're going to want to make it opposite of that. And we're going to multiply that times the determinant of the minor matrix. So it's basically the matrix, again, that is formed when you block out everything else. So first row gets blocked out, second column gets blocked out. And that leaves you with everything else, which is right here and right here. So it's -4, -4, and then we skip over to +3, -1, -2. And the final piece of this process is to look at the third entry right here, row 1, column 3. So we're going to write that one down, keep the sign. So the pattern here is keep the sign, opposite sign, keep the sign. That's the pattern. We'll talk more about that when we deal with the inverse of a 3 by 3. So we're going to multiply that entry by the determinant of kind of everything else. So again, we're going to just block out everything that is sort of included here. Right, this is in row 1, column 3, so we're going to block out row 1 and column 3, and we're just going to use the remaining minor matrix, which is -4, 0, -1, and 3. So we're taking the determinant of those minor matrices and multiplying them by the scalars that we got from row 1. So here we go. Let's do a little determinants. We got 3 times. Now remember, first of all, let me get this out of here. Remember we have rules, right? determinants of a 2 by 2, and that's all this is 0 times negative 2 minus 3 times 3. So we're going 0 times negative 2 minus 3 times 3. Close that off. Plus 2. Now we're taking determinant right here. So negative 4 times negative 2 minus 3 times negative 1. Plus 1 times the quantity of negative 4 times 3 minus negative 1 times 0. That's just 0. So here we go. Continuing to simplify, I've got 0 times negative 2, that's 0, minus 9, plus 2 in parentheses. This is 8. Negative 4 times negative 2 is 8, plus 3, which is 11, plus 1 times the quantity negative 12 minus 0. Okay, so we have negative 27 plus 22 minus 12. So it's negative 5 minus 12. So the determinant of matrix C, a 3 by 3 matrix, is negative 17. And that is your answer. So that was method 1, called the Laplace expansion, cofactor expansion. Let's take a look at a different method. So what I'm going to do is grab onto this guy, we're going to copy and paste it and just kind of bring it down a little bit. And we're going to do the whole process over again. So this time we're going to use a different method. This method is named after another French mathematician, Pierre Soros. Again, he is, I believe, mid-19th century. I'm pretty sure they were contemporaries, Laplace and Soros. So we're looking at a little trick here. He came up with this trick, sort of a mnemonic or a scheme that is going to help us to kind of memorize a little trick on how to take determinants of 3 by 3s. And the rule is, you take your matrix, you have your matrix C, and what you're going to do is take these two sets of entries, so the first two columns, and you're more or less just going to kind of just copy them and rewrite them right here and here. So we're taking 3, negative 4, negative 1, negative 2, 0, and 3. And you just kind of want to close that off a little bit. Alright. If I had the ability to erase this right here, I would. So you can go ahead and do that now if you'd like. Now, what you do with this guy again is called the shortcut, or the rule of this guy named Soros. And the method is really simple. All right, you're probably gonna like this one a lot. What we're basically gonna do is, to find the determinant, which is what we're trying to do, you're going to take this diagonal and multiply them. So 3 times 0 times negative 2 plus the product of these three terms, these three entries in that diagonal, plus the product of these three terms in that diagonal. And then you're going to subtract it from, now this is where it gets pretty fun, so you're going to subtract it from the product of these three going down this diagonal. So it's negative 2 times negative 4 times negative 2 plus the product of these three terms, so that's what, 3 times 3 times 3, plus, you probably guessed it, the product of these three terms, 1 times 0 times negative 1. I'm going to close that really big parenthesis off there because we're going to have to distribute that. This negative right here is kind of a source of, for a lot of students, I think, confusion and common mistakes right there. So anyway, here we go. Determinant of C is 0. That's the product there. 0 plus, let's see, negative 2 times 3 is negative 6 times negative 1 is positive 6. These three are negative 12. Big minus sign. Parentheses. This product is, let's see, negative times negative times negative is a negative 16 plus 27, which is this product, plus 0. So just close that off. The determinant of C is equal to 0, kind of disappears. 6 minus 12 is negative 6, minus the quantity of negative 16 plus 27. So that looks like it's going to be 11. And we get that the determinant of matrix C is negative 17 by using the rule of Soros. So let's see if that's the same. It ought to be. Yeah, it is. So you pick your favorite out of those two. Those two French guys came up with two pretty different ways to calculate the determinant of a 3 by 3. Alright, we're on about 12 minutes here, so I'm going to hustle up here to the end and show you one last method. So I'm going to take this guy and we're going to copy and paste it again and show you one last method. This method, as far as I know, doesn't even really have a name. If it does, then I'm not aware of it, but we are going to simply call it the diagonal, I don't know, shortcut or something. And you might like this one as well. So we're going to take determinant of C is equal to, alright, here we go. So we're going to do diagonals again, kind of like Soros did. And we're going to go these three, multiply those together, 3 times 0 times negative 2 plus, alright, now here's where it gets a little strange, plus you're going to multiply this term by these two. So it's plus negative 1 times negative 2 times 3 plus, now you're going to multiply, let's see, we did that one, we did that one. Now we're going to multiply 1 times negative 4 times positive 3. Alright, so to recap there, what we did was we took the product of the main diagonal, that's what we call the main diagonal, we added that to the product of negative 1, negative 2, and positive 3, and we added that to the product of positive 1, negative 4, and 3. So that's really the only way I can teach it to you, is for you to pick up on that pattern visually. If you don't like that, then don't use it, but I did want to introduce 3 methods to you. Alright, so then we're going to shoot this big minus sign again, and then we're going to hit our big parentheses again. Now we're going to go the other way. So we just went down the main diagonals. Now we're going to take a look at this product. So we're going to multiply 1 times 0 times negative 1 plus, now we're going to take a look at negative 2 times this diagonal. So that's negative 2 times negative 2 times negative 4, and you can probably see the pattern here. 3 times 3 times 3. So this is basically what Soros was doing, but without the sort of the visual expansion. without the augmentation right here. Soros put that out there. With this method, we're sort of just kind of deleting that step. Alright, so here we go. 3 times 0 times negative 2 is 0. Plus 6 minus 12. This is looking familiar. 0 minus minus 16 plus 27. So the determinant of C is negative 6 minus positive 11. The determinant of C is negative 17. Well, what do you know? We've got the same exact answer. 3 different methods. The diagonal shortcut, Soros Rule, or Laplace's expansion. You choose yours. Either way you do it, you should get the same determinant all the way through.